you everybody for coming to the session this afternoon. I'm John Elbon. I'm the, look up here to see what my title is. I work for Boeing and integrate the human spaceflight business that we have. We have a really incredible panel here today, and a meaty topic, I think. The topic is opening the market aperture for opportunities in low Earth orbit. You know, in the 60 years since Sputnik, a commercial market has materialized for launch, a commercial market has materialized for communication satellites. There are some other commercial markets beginning. There's certainly a lot of discussion about commercial markets. NASA's seeding the commercial market for human spaceflight by sponsoring the Commercial Cargo Program and the Commercial Crew Program. Companies like Virgin and Blue Origin are developing suborbital commercial transportation. So what's next? You know, there's a lot of research going on ISS for things like cures for muscular dystrophy, basic research. Companies like Target are doing research on how to manufacture clothing with less water. But is there a killer app out there or a killer use for space, some activities that can only be done in space that will really set us off on a commercial trail? There's a lot of work, I think, done on the supply side of the equation, and by that I mean transportation capabilities and destination capabilities in low Earth orbit. What's coming on the demand side that will develop a commercial market to really pull on those capabilities? So we got a panel here today that I think is well qualified to discuss that. I will, kind of the mechanics, I'll introduce each of you briefly, just a couple lines, and I'll ask you a question. I would ask that you take a few minutes to describe your company, your role, and what you do, and then address the question. And then the process for the audience to ask questions is there are folks with paper. You can get a piece of paper and they'll pass that up so that we can ask questions as we go. We're going to stop this at 40 minutes after the hour to allow time for the panel that follows, and so it will be slightly shortened than what was in the agenda. Okay, let's see. We'll start off with Oliver. To get things in the right order here. Oliver is the Vice President of On-Orbit Services and Exploration for Airbus Defence and Space, so he oversees the European contribution to NASA's Orion program and the operation and utilization of the ISS Columbus module. So the question I had, I invite you to talk a little bit about that, Oliver, and then from your perspective, from your business perspective, what are the dynamics that you see driving the market and demand for opportunities in low Earth orbit? So tell us a little bit about what you do and then address that question if you would.
Sure, John, thanks. Well, first of all, I'm not just responsible for on-orbit services and exploration, but also for the site of Bremen. So we're having the pleasure to be hosting you next year should you decide to come to see the IAC in Germany. So it's a pleasure to be here and to see what kind of quality contribution we can do. Now, from our perspective in Bremen, indeed, we're contributing to Orion. That's, for us, the very classical agency business. If I'm saying very classical, it's a unique of its kind because we're working with ESA and NASA, so we're in a double, let's say, agency situation and collaborating with Lockheed Martin, who's the overall prime of the vehicle. So that is really not a commercial business, right? This is for exploration, doing something that we haven't done before. If I take a look at the Columbus, the European contribution to the space station, this is really where we're seeing that something is starting to change. So if the message that we're hearing since quite a long time that if agencies are focusing more on exploration going further, they can leave the grounds to more commercial activities, we believe that we're feeling already right now that this is becoming true. Just to give you a couple of examples, we are investing currently in a small thing which is called Bartolomeo. Bartolomeo being the younger brother of Columbus. It is sort of a balcony that you're attaching to the Columbus module, but independent of the technical configuration, it means that we're privately investing into space infrastructure that was originally funded with public budgets. So this is still sort of a public-private partnership because something that is not yet fully clear is transportation and the services that we're needing in order to operate our business cases on the station. right? So it must be treated as a public-private partnership for the time being, but there is serious investment. And with Bartolomeo, we're just acting as a broker. So we are allowing others to have access to that environment that did not have access beforehand, which means that now companies, small startups from everywhere in the world can apply to be part of this, and then have access to an environment where typically they would need to undergo a certain process to be cleared for getting access to the station. Right, so we've now, the first contract that we want to sign with an Australian company from Adelaide, Newman Space, and we're just excited to kick this off and see how we can do business out of that. So for the dynamics, if I take a look at that, there's many things to mention probably, but there are two aspects that are important for ourselves. I mentioned already launch, and you mentioned that launch is sort of commercialized, but we believe at way too high cost. I mean, we're part of that game with the Ariane rocket, obviously, but the trend to bring down the launch cost, that is something which is really, really important. The space station is opening a huge window of opportunity because it allows us to socialize launch cost, right? So today, also with Bartolomeo, if you want to bring a kilo, you really bring a kilo and you pay for the kilo. You don't need to buy a full mission to get an in-orbit verification of your equipment. That's a real value add, but we need to continue driving down the cost of launch because they still make up to 80% of the overall equation. The second topic that we're seeing is digitalization. So we're interested in sort of virtualizing the access to the space station when it comes to mission data and operating the equipment that we're flying on the station. So we talk about clouds, we're talking about optical links from the station to the grounds to have broadband real-time streaming data. And if you talk about cloud and streaming data, you don't need to be in space to understand that you will have artificial intelligence robots who are working the data while you're operating. And then why not bring that immediately into your smartphone rather than going by USOT and a process to gather your data. We believe that this is the other part of the value chain where access to data, access to business can be significantly accelerated. And this will change interest into space. It will change space because it will allow the incumbents to focus on something else and have a lot of new players being part of the game. So these are the major trends that we're seeing that we're interested in.
Thanks. Thanks, Oliver, for those insights. A transition I heard in there from where we are with Space Station today to more commercial, reducing launch costs, a couple of themes in there. Very good. Okay, next is Mike Suffredini. Mike is the CEO, President, CEO, and co-founder of Axiom Space. Many of you may know Mike from his previous role as the ISS program manager for 10 years before he started. So I think Mike has a unique perspective of being on both ends of the spectrum, leading a government-led contract and now working on a startup. So Mike, tell us a little bit about Axiom, and then from your perspective, how are low Earth orbit opportunities becoming more and more viable for the private sector?
Thank you, John. Yes, there is life after NASA, it turns out. So, as John said, I run Axiom Space. I have a co-founder with me. His name's Dr. Cam Ghaffarian, who also owns SGT, the company for NASA that operates the International Space Station and trains their astronauts. So together with SGT, we're on a path to build the first commercial space station, which will begin its life at the International Space Station. And then when the partnership decides to retire, it will separate and operate standalone. So to get to your question, when I think about, from my perspective, market viability, I think we have a long way to go. We've come a long way, of course, but we have quite a ways to go. And Oliver touched on a big part of that is the cost of upmass. Now, if we've been in this business for a long time, we all know, we can all proudly say, the cost of a kilogram to orbit's been reduced dramatically, and it looks like the cost of a seat to orbit is reduced as well. But they really have to be at least 50% less than the costs are projected today in order for us to make a viable go at low Earth orbit. And low Earth orbit has quite a few opportunities. Microgravity environment is got huge potential. We all know about the research applications, but I think manufacturing is going to be much bigger than any other market will be. Early on, crew flights will be quite sizable part of the market, but over time, manufacturing, I think, will overtake it quite substantially, just because the natural production of any product that has to be re-solidified in a microgravity environment is a much better product. And there's been a number of experiments over time on orbit. Fiber optics is the famous one everybody talks about today, but not too many years ago on shuttle, there was a demonstration where they had a aluminum titanium alloy that they re-solidified in orbit. It was twice as strong and half the weight. It was a turbine blade they were trying to create. And if you just take that application across different industries, take a turbine blade, and aircraft manufacturing, of course, mass on an airplane is a huge part of the equation, and if you can drive the cost to manufacture that thing on orbit and get it back down low enough, you can see that the number of turbine blades you'd have to build for that market would be giant. And so the way to make that work is twofold. One is you've got to get the cost of the transportation of the ingot to orbit and the material back home. You've got to drop that dramatically. And in addition to that, you got to figure out how to build the facilities in a much lower cost way than we do today. And what that means is we have to start thinking about the requirements that we use today for space and how we modify those or take advantage of what we've learned operating platforms with humans in space, and take advantage of where there is flexibility. So one example of that I like to use with people is today you have all these space qualified electrical connectors. You've all seen them. They're very cool. They'll last 100 years, and they cost like you have to pay for them over 100 years. And we don't really need that. Many of the connectors we use on the ground today, normal connectors, whatever it is you use, are friction fit connectors typically. Some of them are screw fit connectors, and they'll work on orbit. You have to be careful, and you have to be mindful of the safety of the crew, but you can make practical decisions based on our experience on orbit. How you use redundancy can drive costs down, because if you can build a redundant system or dissimilar redundancies, then you're not so worried if a system fails, because the next system can take over and you're okay. If you drive the cost down and you start manufacturing the way we manufacture things here on Earth today, we can dramatically reduce the cost of a system, and you can have the redundancy you need to keep the crew safe. My favorite one, by the way, is water quick disconnects. Any of you guys that have been working human spaceflight know that we have this tremendously difficult requirement for these water disconnects. In fact, it was so difficult, I don't think we ever met it. So we write waivers to it. So we drive this wonderful connector requirements to the point where it's very expensive, massively expensive, and then we write waivers because we can't meet our own requirements, and then we live with it. And the cool thing about a connector that leaks on orbit, because it's so dry in the environment, you wrap a rag around it and you can stop worrying about it. The rag just evaporates over time, you reclaim the water, and you're on your way again. So there's many things. My point is there's many things we can do on orbit to dramatically reduce the cost of the platform. So between that and reducing the transportation costs, those are two major things we really still have to tackle in order to make sure that we can get not only the research, but perhaps more importantly, the manufacturing to the point where it's a business case to go to orbit to manufacture. And when we do that, there will be, I think, industrial race in space that we can't even imagine today. Thanks.
Thanks, Mike. You certainly have a unique perspective on that whole market there. I'm going to jump down to you now, Sam. Sam is the director for the International Space Station at NASA headquarters, and works on keeping station safe and operating, but also looks at what the future of station would be. And so if you can tell us a little bit about that, Sam, and then talk about what you see as the future market for human spaceflight in low Earth orbit, and what NASA's role is relative to that.
Thanks, John. As the only government guy here, I feel outnumbered. A little bit about my job. I've got, like Mike used to have, working for the boss that I currently have is probably one of the hardest things in the agency, along with human spaceflight as a whole. I spent most of my career at other NASA centers besides headquarters, including working as a peer to Mr. Suffredini at some point in my career back in Houston. I also have a unique perspective that I've worked both on the government and the private industry side twice. Started off as a RSOC employee, went to NASA, left NASA, and then came back again. So I know what it's like to not only direct work, but also have to implement the work. And I think that's a very important thing to help guide policy. What my current job is today is to help guide policy and the programmatics of not only the space station that we have today, but how we evolve the space station and low Earth orbit to be more of a commercially driven model. And then getting back to your question, John, our vision is to be able to evolve where we are today from where it's mainly government-driven requirements and government-directed work to be more of a commercial endeavor, much like we buy services and products for commercial cargo and eventually commercial crew, to have the entire ecosystem, if you will, provided by private industry, and the government just becomes one of many customers, where the government pays for what it wants, and then the private industry is able to leverage those investments for other endeavors like manufacturing or tourism or other activities. Now, from my perspective, look on the government side, we still have a long way to go. We have lots of supply, and I agree with Mike on the areas that we need to still work on. The demand side, what's going to be the market, and the cost. The cost of launch is still quite high, and the infrastructure to sustain humans in orbit is still quite high in many areas. So that's two areas where I think the industry, without the government being in the way, another one of your questions, what the government should do and what the government shouldn't do, the government shouldn't be getting in the way to let industry innovate on their own and have NASA back off a lot of their requirements and the like, and in fact let industry leverage have the aerospace industry leverage other industries, whether it be mining industries or communication industries or other, to leverage the technology that they're using and apply it to human spaceflight. For space station, what it means for us is to help industry do some of that innovation in either business models or in research or in technology demonstration to see what works, what doesn't work, including experimenting with a business model that allows private industry to actually profit from the space station we have today. So the evolution, I think, is quite complex. Markets, even the constrained market that we have for human spaceflight, there's lots of areas that still need development. And the future of ISS and the future of LEO will probably be driven by finding what those edges are and finding where the innovation needs to be. And the government can help and they innovate, but we also don't want to be on the end of prohibiting innovation. And so we need input from our industry partners to understand where's the government help and where you don't want government help.
Okay, thanks, Sam. So you do have the only government perspective and don't feel outnumbered. Okay, I'm going to come down here to you, Robbie Shingler. Robbie is the co-founder and chief strategy officer for Planet Labs. And Robbie's company actually has started a commercial business in low Earth orbit. And so I think we can hear a little bit more of the demand side from Robbie. And in particular, Robbie, if you can help us with what can the government do relative to policy and laws that are put in place to help grow sustainable markets in low Earth orbit, to help companies like yours continue to prosper.
Sure. So Planet is an Earth observation company, and we operate 190 satellites in near space, very low Earth orbit. And a lot of that has been possible actually from many people on this panel. I spent about 10 years at NASA. I left NASA, I guess this is my 4th time leaving NASA, to start Planet with Chris Boschhausen, co-founder in the audience, and Will Marshall. And over the last 6 years, we were able to iterate on the engineering system of the satellite and use the International Space Station actually as a test bed. So 15% of the global launch capacity goes to service the International Space Station. And so that is actually beginning to create infrastructure that is reliable and predictable to get access to space and allow for us to practice this model that we call agile aerospace, to redesign the satellite every 3 months based on what we learned from manufacturing it or operating it or new technologies that came onto the market. And now today, we have been able to launch to an operational orbit with two main launches that happened this year, one with 88 satellites and the other one with 48 satellites. And we now image the whole world every day at 3 meters per pixel. We also operate the largest high-resolution constellation satellites at 80 centimeters per pixel, 7 of them, and another 6 of those are going up in about 3 weeks. So back to your question here is around what government policy can do about the involvement in this. So one, I would say 3 things. One is launch, 2 is procurement, and 3 is regulatory. And also as a preamble though, this is an exciting time, right? We are just beginning to get new entrants to come into space and to try out different types of businesses and technologies and sensors. The majority of the commerce in space comes from the bits that come to the ground. That's why we go to space. Or we have launch, we have satellites, we have humans. So if we take the humans to the side, and we talk about the majority of the commerce, it's because of the signals that you get, whether it's your PNT, or whether it's a comm signal, or remote sensing signal, or weather signal. It's about the insight that you can get from that. And bringing the sensor revolution into space, having access to space, means that we will come up, entrepreneurs here and elsewhere will come up with really interesting businesses that we haven't thought of today, right? So it's a very exciting time. But launch is still the largest barrier to innovation in our industry, by far. And while we're talking about it as a commercial market and dollars per kilogram coming down, it is not serving commercial needs, period. To book a launch, then for it to be delayed for months, quarters, years, doesn't really help the business. And so I think the largest opportunity to really allow for near-Earth space to open up to commerce is going to be with small, dedicated nano-launch. So I'm kind of setting that up for you, Rich. This will be something that I think will allow for space to be operated much more sustainably, allowing for students and small companies to get access to space to the correct orbits, but then come up with interesting con-ops and business models that aren't the typical orbits that are currently enjoyed today. So I'm a huge fan of small launch, and I actually don't think that, that governments are taking that seriously. If you think about Elon, and starting with the Falcon 1, he did that with $100 million of his own money. And then he was able to get a DoD contract and then a NASA contract. And the mass majority of what his business comes from is from servicing the NASA contracts. And that has allowed for him to continue to actually build out a business and so forth. But it is, I mean, I'm just going to be honest, it's highly subsidized. So this is not a true market yet. I think that the small launch vehicles are not being helped by government. So we aren't in a true commercial market yet in near-Earth space. Launch is the largest barrier, so if government can do anything, I would say just be overt about it and create some programs that actually, yes. Well, I actually personally want some competition because I don't think that it's happening fast enough, but I'd love to hear your reaction on it. Second, the last two things really quickly is on being a good customer. So for a number of services that happen in space today that the government currently enjoy or currently operate, some of them can be done at a very different price point. That the government can actually more or less say, hey, we would pay this amount for this signal, or this amount for this information feed. And that would allow for entrepreneurs to actually use that as a demand signal in order to come up with new businesses, to get funding, and to also, and then to get an anchor customer. And that's not necessarily the government choosing one particular company or a solution. They're more or less saying, we want this, and we don't know how you're gonna do it, we'll buy that answer if it actually becomes available. So modernization around procurement, I think, is something that is completely open, and again, a number of things that have done pretty well with COTS, for instance, and CRS is also a very good model. And last one is on regulatory. So we currently in the United States, at least, with NOAA operating commercial remote sensing and all, and it is overburdened with the applications, which is great. It's showing a whole bunch of interesting new businesses that people want to start. But that office, and it's currently the level to which it's staffed at, it does not have enough resources to actually have insight into really what is happening within the industry or foresight into what's coming. And I think that that's critically important when the government is helping to create a new market. When people invest billions of dollars or billions of euros into something, they want to be able to know that they're going to be able to operate in that modality. And so that's something that from an industry perspective, it sounds a little strange. We're saying we want there to be more regulation. I want there to be a larger office that has insight and foresight into the precedent that they're setting with each one of the determinations that they make on applications. And so that does mean that we're actually looking for that to be elevated.
Great, thanks, Robbie. 3 meters per pixel, I think I'm still safe for a little while, being observed. So, Alexander, you were next on the script, but I can't help being a moderator turned instigator and switch to Rich here because of the reaction that we had going.
Well, I could not disagree more. When I hear the words governments making markets, I climb a wall. So governments do many things well. Okay, they build space stations, they can do undersea research, they have armies and navies and air forces, but governments are really terrible at building markets. And what typically happens, I think we need to start with some very basic definitions, because this conversation has kind of wandered through the briar patch a little bit. Private sector. Pretty much everyone which is a company that is not owned by the government is in the private sector. So in the United States and Western Europe, most everyone is private sector that is a company. Commercial is something different. Commercial means you are selling in a commercial marketplace primarily to non-government customers. So government contractors, nothing wrong with being a government contractor. There are some great, brilliant government contractors. Government contractors exist to meet the very sophisticated, articulated needs of the government. So what happens when you mix those terms up, and then you do mix them up when you get into public-private partnerships, where you are purposely sort of muddling the water and saying that government and industry should work together. But what happens when you don't keep these ideas separately is you do bad policy. And specifically in the area of, let's focus on launch. Virgin Galactic is building a spaceship. We'll talk about that in a minute. Virgin Orbit, which is a sister company to Virgin Galactic, is building a small launch vehicle. We've invested our own money in pursuit of a market that we see that is a commercial market. And there are at least a half dozen, if not a dozen other companies, including Peter Beck's company, who was just sitting here on the last panel, who are investing their own money to try to meet what is a clear market signal. The only thing the government can do is mess that up. Now, if the government comes in and tries to accelerate a clear market signal. Yes.
So that's a critical phrase, because you have investors, because there's a clear market signal. While I don't disagree that the government screws a lot of things up, and I helped screw things up when I was in the government, there are things the government does invest in because nobody has a clear market signal.
Right.
Yet it's where we believe, or at least as a government entity and the citizens of that government believe we need to go. So
I think the government can articulate its own needs. It can say, we need to go to Mars, or we need to develop a microchip to serve this function. But I do not see the government saying, I need to help the commercial marketplace accomplish X, or I need to establish companies. I just don't think it's the role of the government. I think the government, I just fundamentally disagree.
I think it depends on the market. I mean, you could be benefiting. That clear market signal could very well come from all the work the governments have done to fly space, to put astronauts into space, and now everybody and his dog wants to fly, except they can't afford it, and you're making it affordable. So the government actually created the market that you have.
Well, let's look at the data. We probably shouldn't make this a bilateral conversation, but let's look at the data. What are the markets? The communications has been the dominant market in the industry since the 1960s. Really, communications, it was born. The government played a role, but there was also a very strong market signal at the time because it replaced a technology that was inferior, which was fiber optic cable. Clearly, the government played a role in pursuing its own requirements in imagery that created the technologies that could later be used for what is now a remote sensing industry. So clearly, there's a synergy there. But I think that where the chaos usually happens is the government says it's going to be commercial, or it's going to do something to help the commercial sector. And I think it almost always fails when it sets out to do something that isn't a government function.
But when the government is a large customer, how can the government be a good customer? Because they can send a clear market signal for a capability that they want to buy. And do you not think that the government should be a customer of commercial services?
Again, we're in a muddle there, because then the question that you're asking is, how can a government acquire in the most efficient manner, right? It's really an acquisition question. And so if the government is a good buyer, then it can help the market, it can. I'm sure that Dell Computers has been helped because the United States government buys lots of computers. But it wasn't fundamental in creating the commercial product that is widely sold. So granted, there is a synergy, but I think what the government needs to do is focus on its objectives. And that's what's been so fraught about the space station. The government didn't build the space station for commercial, didn't build the space station for microgravity. It built the space station as part of the journey to the stars that we're on. And we kind of have to go backwards and we re-rationalize it as being something that's going to turn into a commercial. I think the space station, for all the reasons that have already been articulated, is a really difficult example of something that I don't think it will find a commercial market in the next generation. But
I'm gonna try to refocus this here a little bit, Rich. But that was a good discussion, by the way. Thank you, guys.
I got more to add, but I guess we'll move on.
Yeah. So I think there is a fundamental discussion that we get lost in the vernacular. Some people, when they describe commercial space, they think of a market like you described, Rich, where there is a commercial provider for a commercial customer. And I think there's another way that that word is used where, for instance, a commercial station would be an industry-provided, industry-operated facility that would serve the government as the primary customer, at least for a while. So we get a little lost in the discussion there about what we're really talking about. I want to give Alexander a chance. So Alexander is with Energia. He's chief strategist and developing their business there. Does a great job. If you could tell us a little bit about Energia's role, Alexander, and then talk a little bit about the public sector role when it comes to commercial access and human presence in low Earth orbit. What should the government be involved in? What should the government not be involved in?
Thank you, John. I would like to introduce my company too. Probably I should start from the beginning. We launch first satellite 60 years from now, and not so familiar to everybody. We started commercial market, and we continue commercial market, and all have been in human, space flight, and commercial been done by our company. Therefore, we have some practice, and we have some opportunity to, I'm sorry, to speculate about Syria. The most important outcome from our experience is the following. For today, government, I'm sorry, unfortunately, but necessary. We cannot consider commercial market without government basis. We can create something, but government should be in any case. Let's look to the International Space Station. Station now 450 tons, 6 crew members, and tomorrow will be up to 10. We now have almost 20 years human presence on the low orbit. And we have thousands of experiments, hundreds of users. And this is a facility which is absolutely necessary to our market. Now we should consider, and we are trying to develop cheaper, I cannot say faster, cheaper, better, but cheaper station. It is not so easy, because if we will do station which might be less than ISS, we will receive less results. Therefore, we should consider what is the preference. To our understanding, station should be governmental. Station should be governmental up to time we will have production, can be considered as real commercial. Now we have just communications, real commercial, remote sensing, almost commercial. But for human activities, tourist or something like this, it is not really commercial. I need to emphasize for cost reduction issue. My colleagues raised this issue, and this is issue really important. But unfortunately, I need to share my opinion on this issue. We should work hardly to low growth of the cost. We cannot reduce the cost. We had a lot of attempts. Good luck to Elon with his reusability, etc., etc. But it is something not so real today. Maybe tomorrow or maybe day after tomorrow, but not today. It is absolutely impossible. We day by day have growth of the cost. This is our task for commercial future. Therefore, return to your question. We need to have more operator companies. We have a lot of companies who are willing to use their efforts to produce something. But we have lack of operators. We have a lot of operators for communications. We have not so a lot, but many operators for remote sensing. But for human presence, we have maybe a couple of operators. It's not enough. The next, we have support from private sector for utilization, for clients' relations. It is very important to grow the market for us. And we should continue any opportunity to provide additional services to clients, like commercial module, like any opportunity for AVA or other new services to them. And government. Government should regulate. Government should support. Government should continue government task fulfillment. But the most important, government should not be part of the competition. Government should not participate on the market as a contractual body. This is most important issue especially for Russia. I'm sorry for United States too. This is difference between government should provide the field for industry, or government should participate on this field as a player. This is most important issue for us. Thank you.
Thank you, Alexander. Okay, we've got some questions coming in. I'm going to start through with these. Rob, this one's for you. You mentioned that Planet operates 190 satellites. Does this mean that you have 190 that are fully functional? How do you deal with debris as the satellites expire? And how many of those, it says how many fail within the first 6 months, but perhaps a better way to say it is what's the life of the satellites that you have up there?
Sure. So I was mentioning before the majority of the satellites that we launched early in our company's history from the International Space Station at a 400-kilometer orbit. With that's very low orbit. With the ballistic coefficient of the satellite, they last about 9 to 12 months before they, as designed, burn up in the upper atmosphere. So the majority of those have re-entered since they were launched well over 12 months ago. We still do operate a couple dozen of those that were deployed last year. Of the ones that we fully operate in a sun synchronous orbit, we deployed them to a 500-kilometer orbit and a 475-kilometer orbit. Those are also very low operational orbits. And as a result, with the ballistic coefficient of those satellites, they last about 3 years, plus or minus 1 year, depending on the solar cycle. And that's well below where the congested areas are in space. So the congested areas, for those that, first of all, space debris is a problem that our entire community needs to really get serious about. And the congested areas are around 750 to about 1,250 kilometers in a sun synchronous orbit. That's where a lot of expended upper stages are. That's where a lot of that's where a lot of old satellites are that have been up there, and it's a problem. We need to definitely solve it. But us at Planet, we want to fly low. We can get higher resolution for a small aperture size. We want to fly low because we're protected by the radiation environment of the Earth, so that we can come up with novel ways of using more consumer-grade, high-end electronics. And we fly low so that we don't contribute to or get hit by space debris. So that is the way we designed this into our overall concepts of the company, is to be a responsible actor in space.
Great, thanks. Okay, here's a question for Sam and Mike, and others may want to chime in here. The question kind of goes like, we had a discussion about the cost of launch being a challenge in commercializing low Earth orbit. So it's kind of a thought-provoking question. If launch was free, what manufacturing or other capabilities do you see that would happen in orbit as viable commercial activities on board station or another platform. So if we kind of take launch costs out of it, so we got it down to zero, what would that mean?
So for users of space station, it is free. The government's paying for it, so private industry and other government agencies can go to space station for free. Free crew time, free power, free data services, free launch, free landing, and the like. So, however, the station is not geared, the platform itself is not geared towards large-scale manufacturing or anything that's really large-scale. It's all technology or research oriented. We've become a place of choice to do CubeSat deployment, but again, we're not really geared to do hundreds of them, though we've launched quite a few from space station. As far as if launch was free outside the government, you know, in the free market, and I don't know anything that you can buy that's free, other than pain. Manufacturing of some sort, go back to what Mike was saying, is the best hope, if you will, for a commercial market, as using Richard's words, is to develop. It would need to be something that's large scale. I personally don't think there's the other areas like marketing or making films or, you know, or even tourism will sustain that level of investment. So that's what I would say.
How would it affect your business model, Mike, if
Yeah.
launch costs were significantly reduced?
Yeah, launch cost is cool. It's the return cost is a bigger challenge, right? To have the volume of return is a big challenge still today. I mean, there's a spacecraft that does it, but it's relatively small. And if you're going to manufacture in orbit, it doesn't do any good to manufacture in orbit if you can't get your product home, and you got to get your product home in a timely fashion, and at a scale large enough that you can close your business case. So to me, if assuming you have those pieces, which are significant and huge, then again, as I talked about before, I think there are all types of ways to use the microgravity environment to create products that you cannot create on the ground. And so I talked about some. Alloys is a big one, but you got to manufacture the product in space. You can't create the alloy and bring it home, because when you go to use it, at least in most cases, it's not very helpful. Fiber optics is one. One of the most intriguing ones to me is this idea of building human organs in space that you can return. So today we can create one-dimensional skin type, through a 3D manufacturing process, but in the future, on the ground, you can't create organs because they collapse on themselves while you're trying to create them. So microgravity environment gives you that. So I think there are a number of things like that, and really the bigger trick for us than if you gave them free access is this concept that we've started about creating an incubator where we get good ideas in the door and we vet the ideas. Technically, is it feasible? Do people believe it's feasible? And then will it work in space? And if those two work, then we connect them with an investment group to make that investment, and they give us some royalty and some IP, but they get to fly. And a process like that almost makes space like the internet, right? Because why we had the .com boom was that any kid that knew how to program and had a good idea could go create a tool that he could then eventually, in a lot of cases, sell and be productive. So this is the environment next that we have to create if you have a relatively capable and inexpensive launch and return cloud.
John, if you allow just to add a completely different facet of that, we very often think about what can we do for Earth. Let's think about what can we do for ourselves, right? So we've started to think about changing the value chain in satellite manufacturing by changing the design points. Right now we're sizing, so we're influencing mass in a negative manner only to survive the launch, right? So if you avoid that by transporting raw materials or more robust materials, and I think there's a similar effect if you go for smaller CubeSat type of structures, then you can choose completely different design points. This requires that you transfer a certain level of manufacturing and assembly into space, But then you have a much better design point because mass is no longer a driver. This will automatically drive down the cost of launch, even if the launches are not getting cheaper, right? Because you're doing it differently. And this will also have a positive effect on the infrastructure that companies today need to maintain on Earth. So let's get rid of the clean rooms because you have your clean room up there, right? And if you then can go in a probably more distant future into a setup where you don't even need the pressurized housing because you're doing this outside, by robotics, for instance, then we're talking not about a permanent presence up there, but you're talking about a value chain to generate space infrastructure, full space, by man-tended infrastructure paired with robotics. And this is something which may not happen tomorrow, but we're having clear plans to test that on smaller items and just do it the first time and see whether it works and then take it from there. So we believe it's possible, even though it may take a couple of years in order to get really efficient in that. But that's something where we need to think about ourselves as well.
Thanks for that perspective, Oliver. We're going to have to wrap up here. I would say that the discussion kind of focused on, we're at a point of transition. I think all of us believe that there's commercial opportunities out there, that they're going to mature. At the moment, it's taking a lot of government involvement to kind of keep that going. But we're on a precipice of that transition. So I'm going to ask each of you to try hard to limit your answer to 2 or 3 sentences. And what do you think what's a catalyst that can help us through that transition? What are the things that we should focus on to kind of make that tipping point? Anybody would like to start? Thanks, Sam. And then we'll just come down the road.
Thanks, John. I don't see it, and I'll speak for myself, not for the US government or for NASA. I don't see it as a precipice. I really don't see it that way. Our industry, the aerospace industry in general, I would say, is not the IT industry. It is not the data industry. It is not the computer industry. It's none of those things. Human spaceflight is on a time scale that is much larger than what we see in other industries. So I think this transition you're talking about, the transition's happening. We're learning, both the government and private industry is learning how fast this goes or how slow it goes. What can we do to make it happen where it's profitable to industry and to the government? I don't have a good answer. I will say is that having the government in the way, it will definitely slow things down. But I do think government does have probably a strong role, especially in this industry, in building capacity. The government's played the capacity role in many industries, including the airline industry and the semiconductor industry, and go down to other industries where the government ended up being the first customer, first major customer, but then our whole markets grew up around it, but the government did not stand in the way of those other markets. So I think those are the things I think that need to happen.
Great, thanks for going first. Alexander?
May I continue? First of all, we should stop discussions about low orbit to be transferred to commercialization today. We should say low orbit will be, can I say, governmental forever. And we have a lot of tasks on low orbit. It does not mean government contradict with commercialization. Commercialization will be born on the government and will grow when government will support. It should not be a task of one day. It's a huge program. We have a lot of science, we have a lot of commercial tasks, and we will decide. And our first goal is to provide flight opportunities. We should have flight opportunities on the crew vehicles, we should have flight opportunities on the station board. Now we have no flight opportunities. We should create flight opportunities. Thank you.
Okay, thanks, Alexander. Rich?
I can keep it, I think, pretty succinct. I think the government should avoid competing with the private sector. If the private sector is in a market, the government should respect that and not spend money to disrupt the commercial dollars that are there. I think the government should acquire commercial capabilities if they exist. And I think that there are opportunities for partnership that can respect both those roles.
Great.
And I think that last, let me add one more, which is there's a tremendous amount of churn and wonderful dynamics going on in Lower Thornton now, and dozens of companies are coming into being. I think the government will do everyone a service if it doesn't react to either great new companies starting and companies going out of business, because that's what markets are supposed to do. It's supposed to, it's sort of Darwinian. The weak should be culled out so that new companies can start. And so I think the government needs a light hand.
Okay, thank you. Oliver?
Just in a few summarizing words, I think we need to credibly lower the barriers of access to space. And I don't want to be too academic who's doing that. I think if private investors are ready to do that, that's great. If public side is ready to do that, is great. The effect of that will be that we will start driving an orbital economy. And if that really takes off, and many people are doing that, then we can talk about converting it into an orbital society. And the difference of that shall be regulated by governments, right? Because this is what you do here on Earth, that you're regulating by having the minimum necessary laws and regulations either to trigger something or to regulate and protect something. And I believe the more we go up there, the more it will be necessary to have clear rules that lead to a sustainable expansion into low Earth orbit. And not, have all this debris and all these unplanned topics up there. But the key thing is everybody should contribute to lower the barriers of access to space.
Great. Thanks, Oliver.
I wouldn't think I was going to say this, but I have to admit I completely agree with everything Richard said at the end. I think he's right. The government needs to be real careful not to be so hell-bent to make everything level and perfect for everybody that they can't act. So this is a parochial thing for me because I'm living it, but the government needs to know that the way the market works is they go try to find where their strength is, and they push that strength for their benefit. And companies succeed and companies fail. And if it's not allowed to operate that way, then the whole fundamental philosophy of a commercial enterprise will fall apart. So I think Richard's dead on, and I think we need to get the government to think that way. The last thing I'd tell you, and this is complete reverse of anything I thought I'd ever say after leaving the government for just a few short weeks, is we definitely need a policy from the government relative to human spaceflight and how we're going to deal on orbit in a commercial way. So I think that's an important aspect.
And for me, the three things I would say, and again, I still believe I agree with myself earlier, which is number one, access to space, and I think small launch is going to be a game changer. Number two is buy the outcome via a commercial service if it exists. And number three is invest in a good, predictable regulatory environment that has foresight and insight into new markets.
Hey, thank you guys. Appreciate the passion and the engagement. Round of applause for our panel. Thank you all very much.